Good morning, students. Today we are going to see about the concept called logic gates delay. So there will be some problems will be coming from this logic gate delays. So before going to the problem, we have to learn about some concept, some terms called alphabet like small letter G, B, H and capital letter G, B, H. So these are the things you have to study. And if it is using for the single letter, single small letter means it is going for stage wise expression. If it is a capital letter, it will be for the pathwise expression. So small letter G is nothing but logical effort, and B will be the branching effort, H will be the electrical effort. Each and every one is having the formula, and GBH, capital letter GBH is nothing but same logical effort, but it will be like a path expression. Okay, so the first formula G will be equal to, always it will be capital letter G will be equal to pi of G into I, that is your product of sum. And H will be equal to the logical effort, output capacitance by input capacitance. If it is a path, it will be called as a output path by input path. Then B will be like branching effort, on path plus off path divided by on path. So here, if it is a capital letter B means you have to do the pi of BA, product of sums. Okay, and the delay will be equal to D equal to F plus P. Okay, P is nothing but parasitic delay. Parasitic delay is nothing but the number of inputs. How many number of inputs, irrespective of the gate, how many number of inputs if you are connected, that will be called as a parasitic delay. The next one, we'll see the first problem. Find out the logical and electrical effort for the given circuit. It consists of a NOT gate followed by the OR gate, NOR gate, and again NAND gate, then again inverter, and then with capacitor it will be entered. The capacitance value is 20. Inside that number will be present a 10, X, Y and Z. This inside alphabet is nothing but the input capacitance of the particular gate. Okay, the first step, what is the question is find out the logical and electrical effort, meaning they are asking about G and H for each stage. So that's why it is in small letter. If it is a pathwise, you have to find out the capital letter G and the small capital letter H. So G will be equal to the formula is nothing but G equal to logic, that is your value of the PMOS plus NMOS. So PMOS ratio plus NMOS ratio plus in the top it will be the number of inputs in the gate. Okay, so PMOS and NMOS costs will be, that is your width of the PMOS is 2 and your NMOS will be 3. Always the denominator will be following the concept called 3. Okay, and then total number of PMOS and NMOS used in that particular transistor is called as a, it will be placing the role in that numerator. So consider for an example of inverter. In first you take the gate called inverter. This inverter is nothing but PMOS plus NMOS combination. So again you are having 2 plus 1 transistor. So 3 by 3 value will be 1. So G for the inverter is 1. And 2 input NOR gate, it will be the 5. So because 2 input NOR gate, you are having 2 PMOS and plus 2 NMOS. Okay, so 2 PMOS cost, that is one pair of PMOS and NMOS combination will be the 5 by 3. Okay, then NAND gate, it will be 4 by 3. So we're having the general formula G for equal to N plus 2 by 3. N will be the number of inputs and this is the formula for the NAND gate. And G will be equal to 2N plus 1 by 3 and this is the formula for the NOR gate. And H is very simple, output divided by input capacitance. If I take that inverter, output will be the X because output is given to the NOR gate and input will be, there is no inputs here. So therefore it will be like that is capacitance is present, letters will be inside, right? That will be like input capacitance. So H1 for the inverter is X by 10. The next one is Y by X because output is Y, input is X. When we consider this one, that is when we consider the NAND gate, output is Z, input is Y. And when we take the again last inverter, output is your 20 divided by Z because 20 is the output capacitance divided by Z. Okay. Then next problem. Find out the logical and path effort for the given circuit. So again they are asking about your G. Logical effort is G and B F, it will be the logical and path effort, but it will be asking for full path. So definitely the formula will be capital letter G and F. So G will be equal to pi into G. You have to calculate the logical effort for each and every stage, and then you have to finally multiply it. Okay. So G equal to here it is fully connected with inverter. We know that always the logical effort for the inverter is 1. It is a common one because plus sum we solve that one. Okay. So totally 1 into 1 we are getting the capital letter G equal to 1, and the capital letter F will be equal to formula as 3 alphabet G B H. F equal to G B H. G just now calculated. B will be the branching effort if it is having the branches. So the branches formula will be nothing but on path plus off path divided by on path. Some dotted lines will be shown in the circuit, which means that circuit will be on for the below that line circuit will be active, above that line the circuit is not active. So therefore the value of the capacitance, okay, so our on path is 15, off path is your 15. 15 plus 15 divided by your on path value is 5. Sorry, 15. Totally we are having the 30 by 15, we are getting the value of 2. So this is your branch value. So B also we calculated. Now last chance is to get your H value. H is nothing but C out by C in path. Totally output capacitance divided by input capacitance. My output capacitance totally is 90. At last is at 90. At the initial it's 5. So finally I'm getting that 90 by 5 is 18. So totally G into B into H, 1 into 2 into 18. So this will be getting us 36. So this is the logical effect on the path effect for the given circuit. Thank you, students.